So GED students, we're looking at exponents at an advanced level again, and some good news for some of you, but probably not for my YouTube analytics. But anyway, you could turn off this video if your only goal is to get the GED. I don't expect this particular style of problem to show up. However, it is an extension of what we've done. What we've done with exponents can help us to understand this really important college concept. So you're definitely going to see it in your college algebra classes. You're expected to understand it, and it comes right out of what we've been doing. And so that is why we're looking at this at the advanced level. So let's go ahead and take a look at what it asks us to do. It says use the product, quotient, or power rule to simplify. Now, what are they referring to? They're referring to the rules here of simplifying what we call exponential expressions. So these algebra expressions that have exponents in them. And a lot of teachers will make you memorize these three rules when you start using exponents, when you start doing this kind of math. And what I found is my students in particular struggle with memorizing a lot of rules. They get them all mushed up, mixed up. And so what I would like to encourage you is that you can actually use our expanded form we've been learning about when you're in your college classes if you forget your rules. Let me show you what I mean. So you might take a look at this example here. So what does it say? J to the fifth power over J to the fourth power. Now let's remember that one way to think about a fraction bar is divide. So one way to think about this example is not as a fraction, stop panicking, but J to the fifth power divided by J to the fourth power. And you might say to me, Kate, that doesn't make it any easier. Well, if you had your rules memorized, you would know that a quotient is a division expression or its answer. And we talked about that in the basic operations. And so the quotient rule could help me here, the rule about how to divide with exponential expressions. But then you say, well, Kate, you haven't taught me the quotient rule A, but B, even if you did, I probably wouldn't remember it. And that's when I say that lovely expanded form can really help you out here. Let me show you what I mean. I can expand J to the fifth power. I know that there's a way to write that as repeated multiplication. J to the fifth power means the same as the number J multiplying by itself 5 times. So J times J times J times J times J. 5 J's multiplying. Okay, now same thing with J to the fourth power. I could rewrite that in the expanded form. J times J times J times J. And then I don't have to know too much about algebra in order to simplify this. And I certainly don't need to have the rules memorized, because I've known since the very beginning of math that when you have a common factor, a number that could be multiplied in to the top and bottom of a fraction. Maybe that's not a clear way to put that. Let me think about that again. A factor. How about this? A number that could be divided out of the top and bottom of a fraction. Then you can cancel them. Common factors can cancel. You might remember that when we were doing such simple problems as like reducing 4 over 6 to the lowest terms. We said, they have a common factor of 2. I can divide it out or cancel it out of both of those guys. So we see the same idea when it's letters. You might not know what J is, like if it's 5 or 7 or 11, but you do know that it's in both the top and the bottom. It's a common factor. And so every time you see the same number in the top and bottom, you can cancel it. So that J will cancel with that J. 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 And what am I left with? I'm just left with a single solitary J at the top of a fraction. And so what does that simplify to? It literally just simplifies to J. And I didn't need to have a rule memorized in order to do that. Now, you might be saying, but Kate, your directions said to use the rule. Fine, I'll use the rule. I promise you. Any rule in math class is not really a rule at all. It's just mathematicians noticing a pattern. So enough mathematicians did this work right here to see that this is what always happens. And so what the quotient rule does say If you want it written down for your understanding, and so you can shortcut straight from here to here, and so that you're prepared for college, it says when dividing exponential expressions. So don't get all tripped up in my language, guys. I knew I was dividing because of the fraction bar, and exponential expressions, meaning those two things on the top and bottom of my fraction had exponents. You can simply subtract the exponents. Okay, so the shortcut way, they're going to expect you to be able to do this in college class, is say, oh, okay, if I have j to the 5th divided by j to the 4th, I can just subtract the exponents. And you won't have to necessarily write this step right here that I wrote, but you'll need to be able to do that in your head. This is the same as j to the 5 minus 4. I'll just subtract the exponents. Now, of course, 5 minus 4 is just 1, so we're saying that's j to the first power. Now, you might say, well, Kate, that's not the same. I had an answer of j, and this gives an answer of j to the first power. But that's another thing you're supposed to understand about exponents. What does the first power mean? Well, it just means I have a single solitary j. And so the simplest I would be able to write that as expression is being able to write j. So I don't care if you use the expanded form to notice the pattern, just like the mathematicians did who wrote the rule, or if you memorize the rule, but you do need to be able to divide exponential expressions for the GED. All right, if you have any questions about this or any other GED math topic, be sure to drop it in the comments and I'll do my best to answer it.